So today we're doing a deep dive into the extraordinary legacy of Hubert Reeves.
Yeah, what a figure. An astrophysicist who did more than just, look at the stars.
Right. He really connected that huge cosmic scale to, well, to us, to our challenges right here on Earth.
Environmental issues, our energy future,
Yeah.
he brought it all together.
It's this amazing blend of cosmic wonder and really practical thinking.
Absolutely. Reeves was quite special, born in Montreal back in 32, passed just recently in 2023.
And he wasn't just an astrophysicist or an environmentalist, he was a popularizer of science.
A rare gift, definitely.
Mhm.
Making things like astronomy understandable for, well, for anyone, even kids.
Mhm.
He left behind so much valuable work.
So our mission here is to dig into some of that, especially his book Mal de Terre, which translates to Painful Earth.
Mm-hmm.
And we're also going to explore this really fascinating personal story, an incident that really shifted his thinking on energy.
Right. A pivotal moment for him.
Our goal is really just to pull out the key insights from his work, get his unique take on, where we fit in the universe, the environmental hurdles, and where we're heading with energy.
And it's important to remember, like you said, he wasn't about doom and gloom.
No, not a catastrophist.
Not at all. He was very clear-eyed, very observant, offered actual solutions, and this kind of broader view of nature's resilience and our place in it.
He wanted us to get the stakes, but without just throwing our hands up.
Exactly. Understanding without despair.
And that cosmic connection, that's really fundamental to how he thought, isn't it?
Oh, completely.
This ability he had to just widen our view beyond Earth, make you feel like an inhabitant of the universe.
Yeah, that phrase captures it perfectly.
But it wasn't just philosophical stargazing, was it? He directly connected that huge perspective to immediate risks right here.
He absolutely did. That's where the Venus scenario from Mal de Terre comes in. It's a key insight.
Okay, Venus. So he described it as Earth's twin.
Pretty much. Similar mass, similar distance from the sun, even a similar amount of total carbon.
But the conditions now, it's night and day, or rather hellscape and home.
Right. Venus is totally sterile. It's, 460 degrees Celsius?
Unbelievable. And sulfuric acid rain.
Yeah, basically a runaway greenhouse effect.
Right.
Almost all down to the carbon dioxide in its atmosphere. Life like ours. Just
Yeah.
impossible.
And that's a picture of early Earth.
In a way, yeah. It's a reminder of what Earth might have been like in its first 100 million years or so.
So Reeves's point was?
Well, his takeaway was that while Earth probably won't end up exactly like Venus now,
Okay.
we shouldn't just dismiss that possibility entirely. It's a warning sign. Nature is amazing, it's resilient, but it's not infallible, as he put it.
That's a sobering thought. Not infallible. So if it's less likely now, what was the main lesson he wanted us to draw from Venus today? Was it just be careful?
It was more than just be careful. It was a vivid illustration that planetary environments aren't fixed. They can change dramatically.
And we can influence that change.
Exactly. Humanity now has this relatively new power to really alter the atmosphere in a geologically short amount of time. So maybe not full Venus, but the lesson about carbon, about atmospheric balance, that was a direct call to, understand and manage our impact.
That cosmic view really does highlight how fragile things are here. But Reeves didn't stop at the big picture. He dove right into our energy situation. How did he tackle that complexity?
Well, he started with the here and now. The energy sources we rely on, petroleum, natural gas, coal, standard nuclear fission using uranium-235.
The usual suspects.
Right. And he pointed out the obvious.
Yeah.
They're finite. He projected petroleum, gas, and that type of uranium running out before the end of this century. Coal maybe lasted a couple more centuries.
Okay, so the depletion timeline.
But here's the twist in his thinking. He didn't just see scarcity as a problem. He saw it as a catalyst.
A catalyst for what?
For innovation.
Yeah.
He saw it as the thing that would force humanity to pivot, to accelerate finding new energy solutions. The limits themselves would push us towards breakthroughs.
That's an interesting framing. Scarcity driving ingenuity, not just crisis. So what long-term alternatives did he focus on, thinking way beyond our immediate needs?
He looked really long-term, millions of years perspective. Things like fast neutron nuclear power.
That uses uranium-238 and thorium.
Exactly. He saw that as a big step because it massively increases the fuel supply, potentially for thousands of years. And it could even help deal with some existing nuclear waste.
Okay, what else?
Then there's solar, of course, both direct absorption and indirectly, wind power, wave power, hydro from rivers and streams, all ultimately driven by the sun.
Right, and then the really big ones, like fusion.
Yep, nuclear fusion,
Yeah.
basically replicating the sun's process, hydrogen to helium, and also tapping into the Earth's own heat, the geothermal energy deep inside.
Sounds promising, but complex.
For sure. Rees acknowledged that these often need huge investment, big technological
But
leaps.
he was optimistic. He was realistic, I think. He noted the challenges, but also pointed to the continuous breakthroughs we're seeing.
Mhm.
Things getting more efficient, cheaper, more practical, easier to access. He saw a positive momentum building.
It's fascinating how deep he went into the practicalities, and it wasn't just theoretical for him, was it? His views on nuclear energy specifically underwent a really significant personal change.
Oh, absolutely. A major shift.
He started out as a big proponent, right? Saw it as a climate solution.
He did. And you can see why. He often used that striking comparison. 1 gram of uranium potentially yielding as much energy as a whole ton of petroleum.
That's a powerful statistic.
It really is. And you have to remember the context. He was at Cornell in 1956. Nuclear energy was getting this sort of almost utopian spin back then.
This was after Hiroshima and Nagasaki trying to find a positive angle.
Exactly. It was being pitched by some as this potential source of free energy that would end poverty. A very different perception than perhaps we have now.
But something happened. He eventually decided nuclear wasn't the answer. And this involved Hans Bethe. Yes, Hans Bethe, a giant figure. He figured out stars are nuclear reactors, worked on the atomic bomb.
Wow.
And by the time Reeves encountered him, Bethe was consulting for companies building civilian reactors.
And Beth offered Reeves a job.
That's right, at General Dynamics in Detroit. They were working on these supposedly more efficient, fast neutron reactors.
But there was a snag.
A big one. General Dynamics was being sued by Ford and General Motors
Why?
because the reactor was being built close to their factories, and they were deeply concerned about the risk. You know, a major accident, catastrophic casualties.
Makes sense. So where did Reeves fit in?
They tasked him, as a scientific consultant, to basically write a report saying there was no risk,
Yeah.
to reassure everyone,
Put his name on a safety guarantee, essentially.
pretty much. So he spent a week digging into it, and he found he just couldn't do it. He could not conclude the impossibility of risk.
So he refused.
He refused, showed incredible integrity, declined to file the report they wanted, and just went home.
That couldn't have been easy. What happened with the reactor then?
Well, they went ahead anyway.
Mhm.
Despite Reeves's refusal, they made it operational.
Oh, boy.
And about a year later,
Yeah.
disaster nearly struck. An instability in the cooling system caused a blockage, a really serious breakdown.
How serious?
Serious enough that they put the entire city of Detroit on alert, ready for evacuation for a few hours.
Terrifying.
They managed to fix the immediate problem, but the reactor itself was intensely radioactive. They eventually had to shut it down permanently, fence it off with barbed wire. That site, St. Clair Island on Erie Lake, it's still inaccessible today because of it.
That's chilling. Yet, even after that, Reeves still supported nuclear for a while.
Yeah, remarkably he did. For several more years, actually. He even debated Pierre Elliott Trudeau about it.
Yeah.
Trudeau's against nuclear then.
Funny how things change. Both of them eventually swapped positions on it later.
Isn't that something? Yeah.
So what finally tipped Reeves completely against nuclear, even after surviving that Detroit close call, it wasn't just that one incident then.
No, it was more gradual. That incident was clearly a huge factor, a real eye-opener. But his thinking continued to evolve. He started focusing more on the whole life cycle, the issues around extracting the fuel. The growing realization, as he put it, that no one truly masters nuclear. The sheer complexity.
Mentally, and the waste, presumably, and the long-term risks.
Exactly. The immense challenge of managing radioactive waste safely for, millennia. And the ever-present potential for catastrophic accidents, even with safeguards. He summed it up so well. He said, you must almost be perfect to master such energy. It commands precision, and no mistakes are granted.
Wow, no mistakes are granted. That's a high bar.
An impossibly high bar, he came to believe. Because human systems, human organizations, they aren't perfect. Mistakes happen. And with nuclear, the consequences of a mistake can be just devastating.
So pulling this all together, Hubert Reeves gave us this incredible perspective. He connected the dots, didn't he, between the vastness of space and the very real dangers here.
Yeah, the Venus scenario showing our vulnerability.
And then his own very personal journey with nuclear energy, highlighting the immense responsibility that comes with these powerful technologies.
He really did expand our thinking.
Yeah.
Helped us see ourselves as stardust, like he famously said, citizens of the universe.
It's a powerful image.
And his call to action wasn't just to gaze at the stars, but to embrace that bigger perspective and how we live here and now.
Which brings us to a final thought, really building on Reeves's own words. He said, "You, me, we are all made of stardust. Our lives are precious, brilliant, and unique like the billions of points of light you see in the sky. Look around you, seek to understand. You will feel like a citizen of the universe."
Beautifully put.
So the question for us, for you listening, is if we really take that on board, if we are stardust, citizens of the universe, what responsibility does that give us, especially regarding these huge matters of concern on our own planet, climate change, running out of resources, dealing with our waste?
How does seeing ourselves as part of that vast cosmic story change how we approach building, strong communities and create wealth in a sustainable way
Yeah.
right here on Earth?
Exactly. How does that grand perspective shape our path forward? Something to think about.